And this one is the application level denial of service attack on Flower Framework. So just as a reminder of what the topology is, uh, for this setup we have five Raspberry Pis uh, that is powered by a PoE switch, and then we have a server as the superlink. So just for a recall of the attack, uh, the Flower framework by default can handle about 1,000 concurrent RPC requests by default, and each request will require a separate thread, or they're also called worker, to process. These workers spawn as needed, but they will never scale down once they are created. Uh, any gRPC calls are automatically rejected if there are no workers available to handle the request. All of the supernodes have to poll from the superlink every 3 seconds. The poll itself is an RPC call, so if all of the workers are occupied, the superlink will reject the supernode, and supernode will shut down after they get rejected. The last thing is that anyone can shut down the entire network if TLS is not enabled. Flower will handle the request as long as it's a gRPC call. It doesn't matter if it doesn't matter what the content of the message itself is, as long as it is a valid RPC call. However, this does not mean that TLS fixes the problem. So what happens if we turn on TLS? Well, first thing is that non-TLS requests will be dropped immediately without invoking workers. But attackers can still easily attack if they can make a TLS request. So the only way to, quote, defeat this is to obtain a CA certificate that is used for TLS. Now, if you're using a public CA, so this would be typical certificate authorities that you'll see in most HTTPS websites. Then having TLS enabled doesn't make any difference at all. In fact, CA certificates is not a secret because they're designed to be public. But let's say if you have an internal CA, something that only works, something that is only distributed within the company, an attacker can still obtain the certificate via a compromised supernode. So that would be example the drones itself, a compromised superlink, or any other unrelated devices that are possibly not even related to the project at all that might still use that certificate for TLS encryption. So all in all, even with TLS enabled, it doesn't change anything. The fact that any attacker, as long as they can make a gRPC request that Flower will accept, can still easily make a denial of service attack. So here we have a demo. On the upper right is the superlink. We have BTOP, which is a task manager. We can see the highlighted text here, Flower superlink. It has 41 threads at the time. At the bottom is the one of the super nodes. And then on the upper left side, it's the attacker. So here we start up the super node. It connects just fine. And then now we start up the attack. Now we can ignore all the errors on the attacker side. Most of these are not that really important. What's important here is that when we look at the task manager again, we see that almost 1,000 threads are created just for the superlink. So this means that the superlink is already handling the massive amounts of traffic in here. So in just a few moments, you can already see that the supernode is down, because of a concurrent gRPC limit exceeded, which means that they run out workers to process those requests. So the supernodes get to shut down.